Good morning, good afternoon. We are just gonna wait still a few minutes just before starting this webinar. I can see there are still a lot of people waiting in the waiting room. All right. We will start now the webinar, but do not worry. You can you have the possibility at the end just to take a look back on YouTube or on different channels. Firstly, I would like to thank you for joining us for this webinar. It's the 10th of webinar, and I really invite you to look all the webinar we have already done on our YouTube channel. I'm Aurélien van de Kerkhove. I spent the last 8 years working at Amherst Technologies. At the beginning, I'm a chemical engineer. I used to work in the project engineering, and then now I'm more working in the business development department. But I will be the host for this webinar. So I'm not really the guest of honor of this webinar, who is Diego Acker. Diego Acker is our safety manager. For the fun story, he started working at Amherst Technologies almost 5 years ago. He was my trainee. I really enjoyed seeing it. And then I really enjoyed working at Amherst Technologies, and basically the plan was to start working at Amherst Technologies as a project engineer. He had the opportunity to work on 4 different sites before having the opportunity to work for this as a safety manager. Now he's working on this specific topic. He started 2 years ago. That's why I think it was really quite relevant to discuss about more safety point of view of the thermal desorption. So the next 12 months we will have the opportunities to do a few webinars, probably three or 4, and every time different topics on the safety management. For the first one, basically, it will be more about the releases during a thermal desorption. And what we are talking about when we are talking about the releases, we are talking about all the wastes we are generating during thermal desorption, and basically how we address it, how we deal with all those wastes. Of course, the webinar, it's between 20 and 30 minutes, that we are not going to have the opportunity to skim all the different aspects of the releases, but I think I had the opportunity this morning to see the presentation, and it will be a really good introduction, and I hope it will generate a lot of questions and interaction after this webinar. Just before starting the webinar itself, a few practical information. The first one is the webinar will last between 20 and 30 minutes. Please, every time you have a question, just write a question in the discussion channel. I will just gather all the questions, and in the second part, we will address hopefully all your questions. At the end of this presentation, I will send a certificate of attendance of all the people that attended the webinar. I think you have all the information, and so I will let the floor to Diego to jump on this really interesting topic.
Yes, so thank you, Aurélien, for the presentation, and welcome everybody to this webinar. So it will be on management of releases in thermal desorption remediation, addressing gaseous, solid, and liquid discharges. So first, let's take a look at our presentation today. So first, a little overview of our company. Normally, you know us well, but always a little reminder is fine. A reminder of our technology also. Then we will enter in the art of this presentation, so the management of releases in thermal desorption. And we will close this webinar with a case study. So let's begin. So company overview. So who is Amos Technology? So Amos Technology is a technology provider. We provide technology for soil depollution. We are based in Brussels, in Belgium. We are approximately 40 people. We have worldwide operation, and we have our own smart burners manufacturing facility. And it's been 25 years that we are in business. We also have our own lab and R&D facility. So to remind, we are really a technology provider. That's the core of our business. Now let's take a look at the principle of our technology. So we have a little animation here. So basically what we do is that we heat the soil. Why do we heat the soil? We heat the soil to evaporate the contaminant. So you see here with the little dots. And why do we heat the soil to evaporate the contaminant? Is to recover all the pollutants. So you see here that the pollutants are recovered by a tube that the name is the vapor tube. And when the vapor is recovered, it is treated. And in this example, the treatment method is the reburn. So the contaminant goes inside the burner. We use it as fuel, and so it's a clean procedure. We have also another procedure to treat contaminants is vapor treatment unit. It will be showed in the next slide. So as said, we have to treat contaminants, and we have two solutions. We have the reburn that was shown in the previous animation. So you have the vapor that goes inside the burner, or we have a vapor treatment unit. A vapor treatment unit is a lot of equipment that the purpose is to clean the vapor. I will show you more precisely that later also. So let's take a closer look to the reburn because it's important to clarify these points to understand properly the heart of my presentation after. So you have the vapor that are re-injected into the burner. So you see the vapor tube just beside what we call the heating tube, and these vapors goes inside the burner. And then what we call the combustion gas goes into what we call the combustion network. So combustion products are sent up to the chimney and directly destroy contaminants. What's interesting with the reburn methodology is that it reduces fuel consumption and it has zero waste profile circularity. About vapor treatment unit, it's another scheme. It will be, again, more detailed after. So just another look of what it can looks like for vapor treatment unit. So big equipment, and we will clarify this again later. So we talked a bit about how we treat the contaminants, and now we will see the different possibility of implementation of our technology. So we have what we call ESTD, in situ thermal destruction, which is vertical. Then we have ASTD, so we build a pile with contaminated soil, and we insert the burner horizontally. And finally, it's again ESTD, but then the tube are inserted oblique. So here's the three possibilities. So now we've seen a bit the technology principle. We're gonna go inside the heart of this presentation, so management of releases. So management of releases. Let's begin with a picture of one of the projects. It was in Gela with our partner Icaro and client Eni. And we will take some zoom at the locations where we have waste. So first, we are in the batch, and we have cuttings. So indeed, when you drill the soil, you will have an extra amount of soil to treat, and we have to recover it. So here on site, you can see operators that recover the soil and store them in big bags. Then you have combustion gas. So here, combustion gas are coming from the batch through combustion gas network. And here you have the fan and the chimney where the gas can exit the process. Then you have soil vapor emissions. So you have a picture of a vapor treatment unit. So not exactly the same that I showed you previously, but it's another one. And finally, you have condensates. So condensates are the liquid recovered from vapor emission, but with the vapor treatment unit, you will cool down them, and so you will have liquid to manage. I will show you more precisely that after in this presentation also. We have also another view of these condensates. So here it was a project in Corsica. And so you can see a condensate tank, so circled in with a red dot, and also a more precise scheme of that, just to show you how it looks. So let's assess what I told you just in the previous slide. So what are the releases of thermal desorption? We have cuttings, atmospheric emissions with combustion gas and treated soil vapors, condensates with pure products and contaminated water, and site waste. Construction waste like concrete, isolation, and household waste for everything that happened in the site. On this presentation, I will focus on cuttings, atmospheric emissions, and condensates. So we've made the inventory of the releases, and now we want to see a bit which releases is associated with the methodology of treatment. So for the reburn in an ASTD pipe, so reburn again, it's the solution where the vapor are directly sent inside the burner, so recycled. We have for releases contaminated water and combustion gas emissions. If we use a vapor treatment unit, we have contaminated water, pure products, combustion gas emissions, and vapor emissions. No cutting. If we are in an ESTD batch, and we are in reburn, it's the same than ESTD pile, but this time we have cuttings because we have to drill the soil. And if we have a vapor treatment unit, we have all the possible releases in thermal desorption. So we've seen the inventory of releases and how it is associated with the methodology we want to choose for the depollution. We're going to see how we manage this. And we're going to see how we manage this regarding of three main pollutants: mercury, fluorinated hydrocarbons, and mineral oils. So for cuttings, so you have cuttings to manage because you drill the soil. How you're going to manage this? So again, cuttings, it's relevant for chlorinated hydrocarbons, mercury, and mineral oils. You will have the same methodology. The only things that will change is that if you are treated mercury or chlorinated compounds, maybe the PPI, so the protective equipment, will be different and maybe some procedure to do it safely, but it's the same principle. So I took again the picture I showed you previously, where you can see operators recovering cuttings from the drill, from the borehole, and store them in big bags. So we are at this stage. Then you have three solutions. First solution, and the easiest one, you call an external company to send these soils to a treatment facility. Second solution, you can have a small container dedicated only to treat this extra amount of soil. That's something Amherst can provide as a solution. And so these containers are equipped with a vapor treatment unit, can also work in reburn. And what's interesting here is that it can manage the pollution directly on site. And finally, last solution is to pour the extra amount of soil and pour a new layer of soil, and then you can treat it. So you will a bit elevated the soil level. That's a solution. It's not always feasible on site, but it's good to know that it exists. Then you have soil vapor emissions to manage. We've seen cuttings, we pass to another category. Let me take a laser pointing. So vapor emissions, how it works, how we manage it. Doesn't work as I was expected. Go back. Okay, no laser, sorry. So first solution, you are in reburn, which means that you have low to mid hydrocarbons pollution. And again, you have the small photo as a reminder. So for these emissions, it's easy. You inject the hydrocarbons vapor inside the burner, and it can be released to the chimney. Now, let's look back to the vapor treatment unit, which concern fluorinated compounds, mercury compounds, and highly impacted mineral compounds. You have a little reminder of the vapor treatment unit, and it's a bit the same process that you will see in this slide. So vapor treatment unit. First thing you want to do with the vapor treatment unit is to cool down the vapor. It's the first thing to do. When you cool down the vapor, you will have an amount of condensate, and the condensate has to be recovered and goes to a condensate tank. So first thing, cooling. Then you have cooled down your vapor, you have a lot of condensate, but you have still moisture in your vapor. You have droplets, moisture, and you want to remove it from the process. So we have what we call a demister. And the demister, we also provide a lot of condensate that you have to recover. So in this picture, I know it's a bit little, but you can see that knockout is the tank that has the demister inside. So it's the same thing, knockout demister. And you can see that the condensate goes to a condensate tank, and it's the principle of the shim you can see here. Once it's done, you have two solutions. First solution that concerns chlorinated hydrocarbons and mercury, it goes to an activated carbon treatment. So the vapor goes to activated carbon filters and to be purified, and then can be sent to the chimney. Second solution for mineral oils, they go to what we call a thermal oxidizer. A thermal oxidizer is basically a big burner where you will burn all the pollutants so that it will be combustion gas products. But sometimes you have combustion gas products, but still too toxic to the environment. So we have what we call catalyzer. Catalyzer is something you have on your car, things, and it can convert toxic compounds or on more friendly one. And then it can be released to the atmosphere. So that's a general principle of soil vapor emission management in the operating way. So you are at the end of the process, you are at the chimney, and then you have norm to respect. and this norm varies from a place to another, and even in the same country, you can have different norms. So I took few norm of monoxide carbon, mineral oils, volatile organic carbon, and mercury. And I compared this with Brussels, so our quarter, and France. And what's interesting is that you can see, like for monoxide carbon in France, even in the same country, you have different norms, which has obviously an impact on our process, because if the limits of emission are different of what we expected, it can have an impact on our treatment and on our design. So it's something that we have to know on an early stage of the process. And what's interesting also is that you can see that for mercury, the concentration is very low, 0.05 for Brussels in France. So we have some norm in commons. Sometimes it's different, but now we are at the chimney, we have limit emissions, and let's take the situation that the limit emissions are reached. What we can do? So you have emission issues. First thing you want to do is to adjust the process. So you will look at your heat exchanger, at your demister, at your thermal oxidizer, at your burners, and see if something is wrong. If everything is running properly, the second solution is to change the activated carbon. Why is it the second solution? The second solution because activated carbon is the expensive consumable on the project, and you want to conserve it as much as possible. And it's also why in the process we will cool down as much as possible the solid vapor, and we want to remove the droplets is to conserve the activated carbon because it's expensive. And then final solution that's not an operating measure, but more an emergency measure, is to adjust the heat of your burner. Normally, if the soil have been correctly characterized, you don't have to do this. It's only if we have something unexpected in the soil, a highly concentration products that wasn't managed during the early stage of the process. And so last solution, but normally if everything has been correctly communicated, we size it good at Hammers Technologies. So we've seen solid vapor emissions. Let's continue with condensates. So you have a little reminder. Let me take the point closer. You have to abandon this just after, but so you can see the little reminder on the screen with the tank. We are at this stage of the process. I will say again if it works. Doesn't work. Not too bad. Come on. So we have your condensate tank. What do you want to do? You want to separate the product from water. And to do that, you will have separators. And separators work a bit differently on the products. Let's take a look first at the mineral oil. So for mineral oil, you will separate the oil from the water because with the fact that oil is lighter than water, so it will go on an upper layer from the water. And then these oil are sent to a separate tank. And the basic way to manage this is to send it to a treatment facility. Then you have your water. What you can do with your water? Water, you can send it directly to the sewer or to activated carbon for treatment, depending on the concentration and the legislation where you are. So solution, directly to the sewer or go for activated carbon for treatment and then can be sent to the sewer. For chlorinated compounds. Chlorinated compounds, it's the same logical, except that chlorinated compounds are heavier than water, and so it will be on the bottom of your tank, and you do a separation also. Chlorinated compounds goes to another tank, is recovered to be sent to a treatment facility. And the water, same logical, directly to the sewer or to an activated carbon for treatment. Final example, mercury. Mercury is a special case because mercury is way more heavier than water. It's 30 times more heavier than water, so you can't pump it to another tank easily. So what's the solution for mercury? Is that the mercury will stay in the same tank as the one you recover it firstly. And you have the water that will be in the upper layer of the tank that will be sent to activated carbon for treatment. In this case, there is no universe you can send it directly to the sewer. It has to go to an activated carbon for treatment. Again, let's take a look to the norm. So you are at your sewer and what you have to respect. So we will compare Brussels and France again. And for 3 pollutants, so mineral oil. So 6 HY is mineral oils, volatile organic compounds, and mercury. And you can see that you have some norms that are a bit tricky and it's strange. Like for Brussels, mineral oils, you have a problem is if it's visible at eyes. So like you have a puddle of oil on your water. For the rest, you can see VOC that it goes to 0.01 to 150, depending on the nature of your VOC, because VOC is a large category of compounds. And so you can see for also mercury, some difference in France and Brussels. Like Brussels is way less tolerated than France. Don't know if this sentence was very good, but I hope everyone understands me. Again, if limit discharges are reached, we have multiple options. So discharge issues. First thing you want to do is to adjust the process. So you go to the separator and see if everything is running well. Then if everything is running well, you change the activated carbon. And if you still have a problem, which means that we are in the same situation as for soil vapor emissions, that we have an unexpected pollutant or the soil was badly characterized, you have to adjust the heat. Last solution. Let's take a look at a small case study. So this case study is about a project in France. So the project is located in France and we have a mineral oil pollution, approximately 5,000 milligrams of pollution by kilogram of dry soil with a volume of 2,000 cubic meter. And our technical approach on this project is ESTD in river. So that's the project. But why this project is interesting is because we have strict emissions control on these projects, and we have to do continuous measurements. How can we manage continuous measurements? We will have what we call a sampling device, like what Hammers call a sampling device. So what's a sampling device? A sampling device is basically a lot of monitoring device connected to a computer. So you have how it looks on site. And what does this computer? First action, it will transfer the data to Hammers Technologies Dropbox for automatic report generation. These reports are then sent to the client. Second action, it will send an alarm to the operator on site on his mobile phone for burner regulation. So the operator will receive an alarm and he knows at this moment that he has to go on site on the burners to see if he has a faulty burner or a problem. How does it look in with a graphic? So as I said, we have continuous measurements, and you can see that all the dots on the graphic are emission point of emission. You can also see the releases limit. Monoxide, carbon, we have 50. and for mineral oils, we are at 10. And you can see a bit how it looks. For this graphic, there are emissions on 1 day approximately, and just to see a bit how it works. We are at the end of this presentation. Thank you everyone for listening, and I'm waiting for the questions now.
Well, thank you very much, Diego, for this very interesting presentation. I think it was really enjoyable to have this pragmatic approach in thermal desorption. You know, talking about specifically where comes from the different releases and basically how we can manage it. I will just take a look if there are any questions in the Q&A, but I have a few of them, and maybe we can jump back to the slide 18. Here you can see it. Here we go. Yes, exactly. Here, maybe I think it will be interesting because here we are understanding the logic, the rationale behind it, but basically we do not have any number when we are discussing.
Mm-hmm.
And so could you maybe just highlight us and explain us maybe how often do we have to change activated carbon when we are working with a VTU? What's maybe the main parameters that will design the different changes? So can you just give me more crusty information?
Yes, so I will be on the activated carbon filter on this one. So for activated carbon, it depends. The activated carbon design will be depending on the pollutant you have to remove from the soil. So I said we are. I'm thinking about how to say it on a basic way. So activated carbon is designed to recover the pollutants when we assess that it has been cooled down and condensate as much as possible. So the pollutant has a capacity to be condensate at a temperature, a maximum temperature. You have the temperature where you can condensate as much as possible of pollutants, but you will have an excess of this pollutant then on your process, and the activated carbon is designed to take this fraction of pollutant in the process. And so for the size of the activated carbon, generally we want to change it not that often, so like every 2 weeks, every 3 weeks, depending a bit of the place we have on site also, and generally we work with an external company to do that. For the fun fact, at the beginning we were doing this, but we understood that it was more, it was way easier to have an external company to do that.
Okay, so here that's interesting about what you're saying. It's basically the frequency and how often you are gonna change it will be strongly dependent on the quality, the efficiency of the condensation you could have. So that's probably why it was a tough question to answer. It basically depends on the quality of the condensation you have. That's also why it's really important in the design that we take into account it. Another question was in slide. It's just the next one, so it's not gonna take a while to go there. Here, it's of course we are working internationally, and so the regulations are really depending on the country. And if you just take a look in Belgium, it will be different if you have the French part, the Flemish part, or in Brussels part. My question is more specifically about the choice of the vapor treatment unit. A vapor treatment unit is really expensive, and the idea is it's complicated to meet the standards. I mean, for the CO, the CO2, the water, it's quite straightforward, quite easy to reach it. But when we are talking about the corrosive compounds, we cannot use a reburn. But besides, it's pity to install a bloody expensive vapor treatment unit. So the question is, can we imagine this example? We have hydrocarbons contamination, and you have a really residual concentration of covalent compound, a low concentration, would it be an issue to use a reburn in this case?
In this case, for covalent carbon, depending on the amount of sol, you could just ignore it for the process, because you can release chlorinated carbon at the chimney, and if it's very low concentration, no issues for the reglementation. If you have more concentration of chlorinated carbons, you may also use reburn, but with another technology that AML has developed, is what we call thermoreact. So the thermoreact is a compound that you will mix with the gravel around the vapor tube. So that's when the contaminant vapor goes through the media with gravel and the thermoreact, it will react in an inoffensive compound, and then you can release at the atmosphere proper emission.
Okay. Okay, that's interesting, because the way it's, I mean, I'm working the business development, and when we can avoid using expensive vapor treatment unit and to have some technology, so that's good also to know that if we have really low concentration in chlorinated compounds, we could still imagine to use a reburn mode. I cannot see any other questions, but the time is almost done. So just thank you for joining this webinar. Here, the webinar was more about technical parts of basically where it comes from the releases. The next webinar will be more about a sustainable point of view. And just after this webinar, you will receive a certificate of attendance. If you have any question, just please feel free just to answer and to send directly a mail. We can address and we can answer the questions just later on. Thank you, Dego, for your time. Thank you, the team behind the computer, for making sure that we can do the webinar and talk to you probably next month. Have a good lunch.
Good lunch, everyone.